What's up, DIYers? Welcome back, I guess. I don't really know. It's been a while, but I am excited. Just started a fire. I got my first help me email I've gotten in a long time, and it's all about Git. What is Git? How do I use Git? I don't understand what the purpose of Git is. Now, I have a bigger tutorial planned, and I will get to it along with a lot of other stuff, but I wanted to kind of quickly touch base because I believe Git is a vast tool. It's a great tool, but I think personally you can get a lot done, protect yourself, protect your project without going crazy deep into the project that is Git. So let's open up the laptop and get started. So for starters, what is Git? Git is a distributed version control system. What does that mean? Well, basically some version control systems have a master record. That master record lives up in the cloud or on a server or in somebody's computer in your office. That's great, and it does a similar job to what Git does, but the difference is, and where the strength comes in of Git, is you have a distributed system, which means your local copy can be the same and have all the same information as the main master copy can have the same information as somebody else's copy. You can do all your work there, push the changes, and it merges very gracefully overall. Now, if you change exact lines as somebody else, then it's going to get a merge conflict. But the tool is powerful. It's the most widely used version control system out there. So let's just dive right into how to use Git.
So to get started, we're going to go ahead and jump into GitHub here. If you don't have a GitHub account, just go to github.com, and I guess I would need to sign out. Let me pull up a different browser here. So basically that's what it looks like. You can either log in or you can create an account. It's free. It's a great little tool. I'm going to go ahead and close this now. We're going to start a new project. Start project. Let's call this Git demo. Showing you how to use Git. Alright. Well, we'll go ahead and initialize it with a README. We're going to create the repository. And there you go. You're using Git. It's very basic. But let's go ahead and just download. We're going to clone this. We're going to use SSH. I've already set up an SSH key. The link in the top corner here. That will take you to the SSH tutorial on how to do that. But for now, let's pull up our terminal. Alright, now our terminal is up. So we're going to go to the desktop. And we're going to create a new folder. Make dir. I guess it would help if I actually put a directory name in there. Demo. And we're going to go into that demo directory. And we're going to do git clone. And paste this new little key in here. It's going to say, do you trust this? Yes, I do. And then now you have a new folder called git demo, which is your actual repo. So now we're going to go into Git. We're going to do cd git demo ls-la. None of that's Git. That's all just terminal commands. So now we're actually going to do a little bit of Git. So you see the README file that came down. So what I'm going to do is I'm going to go ahead and open that. And I have a shortcut, but you can also just go directly to this folder by going to it on your desktop, the demo folder, and it's right there. And you could just drag that down to your Sublime Text or whatever editor you use. This guy over here, my trackpad's going out. I'm not very happy about that. So now we have a README and nothing else. But I'm going to add a little index file here. So we're going to say index.html, save that. And we're just going to do a quick, super quick HTML, perfect. And we're going to say h1, check out this Git demo. Woo! And we're going to save that. What does that look like? That just saved. How does Git know anything about this? Well, if you list out your directories here, you'll see that there is a README, our new index.html, and then this little hidden Git file. This Git file stores all the information about your repo, your commits, your code changes, pretty much everything. It's constantly monitoring what's going on. So if you did git status, it would let you know that, hey, there's one untracked file, so a new file that you added that Git has not done anything with. That you haven't added it to the repo, you haven't committed it, you haven't pushed it to the repo either. It's just out there, so it's untracked. But it's also letting you know that your branch is up to date, which right now we're on the master branch. So let you know that nothing is added to the commit, but there are untracked files. So use git add to get them to be tracked. So let's go ahead and do that. So we'll do git add all. We'll also just do index.html, which is simple, and that's fine. But if you're working on a project and you've got 30 files that you touched, and this list is 30 files of updates, a list of 30 files that are due to be pushed up to the repo, then it makes more sense to just use the period to add it all. So we're going to say git add all, git add. Now let's do git status again, see what that looks like. All right, so now you're saying your branch is up to date, you're on the branch master, changes to be committed. To be committed is the key there. So right now, you have added it to a commit, but you have not actually committed that code to the repo. So let's go ahead and do that now. So we're going to say git commit -m. So that means you're going to put a commit message with your commit. So I'm going to say initial HTML file created. And we're going to hit that. And now we do git status. And it's saying on branch master, your branch is ahead of origin master by 1 commit. So what that means, you have the repo sitting out here on GitHub, and this repo, as of right now, still only sees your initial commit. That's the one that was created automatically for you by GitHub. So it doesn't even know anything about these files yet. The file you created here, the commit, it doesn't know anything about that yet. So that has 1 commit. Your file here has another commit, but you haven't pushed that to the remote repo. So your repository on your laptop or desktop or computer is now 1 commit ahead of the remote repository you're working off of. So how do we fix that? What we actually have to do is we have to take that commit and push it up to origin master. Pushing it up to origin master will make your commits on spot, and everything will be up to date, your local and your remote. So let's see how we do that. So we're going to say git push origin master. So that was a successful push. So let's pull GitHub back up, and if we reload, if we reload here, now we go to git demo. Now you see your index file, 2 commits, 1 branch, 1 contributor, which is me. And if you come back to your terminal and you say git status, nothing to commit, working tree is clean. So basically everything is up to date on your local and everything is up to date on your repository, so you're good to move on to the next task. This is great. Now the question is, does that mean I always have to use GitHub? And the answer is no. So let's back out here. I'm going to do cd ... which is going to take us back to our demo folder. We're going to do make dir, which is going to be, we're going to say git local demo. And we're going to say cd into git /local -demo, not slash. And now we're in here. So now if we do ls-la, which lists all the files, well, there's no git file there. There's no .git folder there. Why not? Well, that's because we didn't clone anything down from GitHub, right? So how do we start from scratch locally without a GitHub or a Bitbucket or whatever? How do we do that? And it's actually pretty straightforward. So we're going to say git init. Boom. So now .git is there. So now there's a catch to this. So when you git clone, it comes down with all of my trackpad is not working. So now here's the catch. You still have to use a GitHub or a Bitbucket or whatever GitLab that you want to use, but you're going to do it a little bit differently. So instead of you creating a project and then pulling down the files, you can actually create a project. This is a remote server. It doesn't know what your actual code is about. It doesn't know what your local is about. It is only there to store your projects once you push it up there. So you still have to start a project to let it know, like, hey, this is a new project. We're going to call this, what did I call this? Git local demo. Starting from local. And then, yeah, we'll go, no, we're not even going to initialize it with readme this time. So we're going to create repository, yeah? You literally have nothing in this repository. No files, no nothing. But you do have a new URL for your repo. So now we have to associate the local copy of your project, of your repo, with this remote repository. So how do we do that? So you say git remote add origin, and you paste that link. So now we have git status. There's literally nothing in this folder at all. So I'm going to do Sublime and open it up automatically. I'm going to go ahead and close this one because we're pretty much done with that. Bring this bad boy over here. Our nice big empty folder. And so we're going to say new file. We're just going to call this readme.md. This is the original commit of the readme. Readme, Seymour, readme. Okay, save that, hide that for a minute, and then we're going to come in here and get status again. Haha, okay, there's a readme there. So we can just say git add all, git commit. We're going to call this initial commit. Git push origin master. Reload here. Boom, you have your first commit. So you have your readme file, and you can add and flow from there.
So great, you can track changes. That's awesome, right? Like that's cool in and of itself. But branching gives you a whole other level of control. You can take the master copy, your repo's master record, all the file changes, all the files, everything. You have where you are in production as your master traditionally. So how do you develop on that without affecting master? Branches is the answer to that. You make a branch, you do your work, and then you merge that branch back in. So basically what it does is it takes the version of the code you want. Usually you branch from master, but you can branch from a branch too. But you branch from master, you create a branch, and that takes all the code that's in master, puts it on a branch. That branch now has all the code that's on master. You can change it. It changes the file structure of your folder to match your branch. So if you delete files in your branch, it won't delete a master until you merge it back over. If you add files in your branch, it won't add it to master until you move that over.
So I'm going to go ahead and add another file to our project here. Now that we're on, I'm going to move this over here. Oh, come on. There we go. So I'm adding a new file here. I'm going to say new file, save it, new functionality.html. And we're going to do HTML. Oh, cool. Or say some new functionality. Save that. So now we're going to say, okay, let's look at what this looks like. Yes, ls-la. So we have the new functionality.html in there. Great. This works just like it did before, right? Sort of. Now let's, just for fun, let's git checkout master. So what if we do ls-la? Well, it's still there. Huh. That's weird. What's the point of a branch? Well, if you think about what we just did, think about how we committed to master. We added files, we committed to master, yeah? Let's do a git status. new functionality. It's untracked. Well, so it's just a file in that folder. So Git doesn't even really know. It knows it's there, but it doesn't know anything about it yet. So how do we add it? So we're going to do git add, but we're not going to do git add in master. So I'm going to git check out again the test branch. And now we're going to say git add. We're going to do git status here. Again, new functionality still has not been tracked. So if we would have added it to master, it would have been tracked by master. But we're not. We're adding it to test. So we're going to say git add all, git commit, adding new functionality. I cannot spell today. All right. And then we're going to do git push. Well, actually, we don't even need to do that yet. So let's do git status. So we're on a test branch, nothing to commit, working tree is clean. All good. So now let's quickly git checkout master. Let's dash this. We're going to list our files again. Well, wait, where'd it go? What happened to our file? This is where the power of Git comes into play. That file did not get deleted. That file is tracked on a different branch. And because we switched away from that branch, that file no longer exists in master. Why is that? Well, say you have a website and your boss comes to you and says, hey, we want to add this new functionality. We know it's going to be a little tricky and we don't want to affect our production stuff until we know it's fully baked and ready to roll. How do we do that? This is where branching comes into play. When you get into agile and bigger teams, this becomes a little bit of a different tool. The same concept, but much more granular. You can go as granular or as broad as you want, as a single developer or as a couple developers, but when you are working in a team of 30 to 100, you have to be super granular. You can't be broad. You have to be whatever ticket you're working on, that is what your branch is. And it's a great way to do things, and I highly recommend it, and I will talk about that in future videos. But for today, let's pretend that test is a new piece of functionality that your boss wants you to create without affecting master. So you can actually create test, and we'll go ahead and check this out. If you look over here, it's even gone from your folder now. Your file structure has changed. So if we go back to git checkout test, that file's back. So you can literally work on this locally as a totally separate project that started out with the same code as master, but has now added new functionality. Actually, real quick, I did want to show you guys something. So if we do git checkout master, if you do git, remember how we switched, we did git checkout master, git checkout test. If you do git checkout -b and you create a new, just let's say test 2, that will actually create the branch and then check out that branch at the same time. So before we just created a branch and then we had to come and check it out. This will actually create the branch and then check out that branch. So you're working on that branch immediately.
So the last thing you need to learn is merging. Merging, you take the code you've worked on, whether it's a functionality or a bug or a new feature, whatever, you create it on that branch, and you're like, all right, fully baked, it's been tested, it looks great, I'm ready to make that part of the product, the live product. That's when you would merge your branch back to master. So that means you would take that code, a piece of functionality, and say, okay, all the files I added or all the lines of code I added, I want those in master. What Git will do is it'll take that code, merge it together, and say, all right, I'm going to go line by line through all this code. Does it conflict? Which means, did somebody else write a line of code in master that matches the line of code that you wrote, and is it different? Is it significantly different? Then I'm going to give you a merge conflict, which we'll talk about in a sec, and it'll ask you to pick which line is right or which piece of code is right. If there's no conflicts, like no conflicts that are outside of like, oh, hey, there's an extra line here that wasn't here before, as long as you're not overwriting anything, usually it'll do it gracefully on its own. So you merge all this code in, now you have it in master. So let's see how that works.
Your new added functionality is done. You've tested it. It has the same code as master as its base, but you need to take the work you've done in test and take it to master. So how do you do that? It's actually pretty straightforward. So what we're going to do, if we go to git checkout master, we still just have the README file, right? So how do we bring that file over? How do we bring, or files? How do we do that? Well, you merge. So you have a master branch. What you do is you check out the branch that you want to merge into. So in our case, we're ready for our stuff to go to production. Master always goes to production. We're going to bring our test branch into our master branch. So let's go ahead and do that. And it's really straightforward. So we're going to say git merge test. Now, ls-la gives us README and new functionality. You come over to your repo here, you have README and new functionality. This is where the power of Git happens. So now you have taken code that you tested independently, did not touch on master until now. So now you have the ability to work independently. You can create as many branches as you want. You could have 100 different branches working on 100 different pieces of functionality, which is what happens when you have a team of 100 developers. They're all working on things at the same time. So how does that happen? This is how it happens. It allows you to work on a piece, merge it in, and what we didn't get into is merge conflicts, rebasing, things like that. The stuff that'll go into the more in-depth Git tutorial, but for the most part, you don't need to worry about that. The biggest thing you're going to run into typically is merge conflicts. So when you have new functionality, so let's go over here real quick. Let's check out git checkout test 2. So now this has a new spot here, yeah? So let's go ahead and add a new file. So we're going to call this new functionality again. New functionality. .html. Save. HTML. H1. Some new function. Save that. Git status. Git add new functionality. Git put commit -m testing functionality. Then we're going to say git push origin master. So everything worked. Why did it allow me to create two of the same file names? Well, we haven't merged it down yet. So let's git checkout master. Now we're going to say git merge test 2. This is asking like for basically a commit message because you're merging and it's creating a new commit automatically. I usually just save it with just that and hit enter. Merge made by recursive strategy. What does that mean? Well, I created a brand new file. Yeah, brand new file called new functionality. But it looked literally the exact same. There was no difference in the file structure. So Git figured out that, well, this is the exact same file. Somebody just wrote it again. It just happened to be the exact same thing. Now, if that file would have been different, it would have blown up a little bit, and you would have had to figure out, like, okay, am I going to rename this file, or am I going to change the text of this file? But what if we create a new branch? So we're going to say git checkout -b merge test. And we're going to say, so new functionality looks like some cool new functionality. So let's save that. Git add, git commit, testing merge, git push origin master. And then we're going to do, and that's just always getting your, so like if my computer were to die right now, the code I just wrote will be out on GitHub, and I can just get a new laptop and keep rolling. So now we're going to git checkout master, and then we're going to say, okay, we're going to merge, git merge test. So this used fast forward this time. So what happened this time was it said, hey, this file looks very similar, but I see one code change here. Some cool new functionality. So it added the new word cool in there. Not a big deal. So now let's create an actual merge commit so you can see what it looks like, because it can be a little bit jarring the first time it happens to you. So let's make this a little bit more verbose. So we're going to say this is a simple tutorial on how to create a merge conflict. This should be fun. All right, save that. Git add git commit -m test merging. Oh, sorry. And then we're going to git checkout merge test. And this should change this file. Yeah. This one we're going to say we are going to have some fun creating a merge conflict. Get ready for some fireworks. We're going to save that. We're going to git checkout, or we're going to git add first. Git commit, testing merge. Your commit should be more verbose than that, but I'm just trying to hurry through this little demo here. And then we're going to git checkout master, and we're going to git merge test. Boom. Now we have conflicts. So now what do? Auto merging, new functionality, conflict, content, merge conflict, and new functionality.html. Automatic merge failed. Fix conflicts and then commit the result. So, whoa, what the heck just happened to my file? What are all these weird lines? So head is where your current repo is before you tried to merge in the new file changes. The thing below the line is the thing you're trying to merge in. And it's saying, hey, there are two lines that look kind of similar, but they're not similar. They're on the same line number, but the text is too different and too difficult for me to figure out. You need to do it. So it's saying this is what the head looks like. This is what you're trying to merge in looks like. What's the right one? And then you just manually edit this and say, okay, I don't like this wording. I like what I was merging in, which is why I was putting it in there. So you delete what's left. You save that. And then you do git add all, git commit -m, fixed merge conflict, and git push origin master. That's a merge conflict. You have to manually remove it. So you have to really be thoughtful in how you're creating files and how you're updating files. For one quick little last check, we're going to go ahead and reload our git local demo here, see what it looks like. So now we have 8 commits. We only have 1 branch. Well, now why do we only have 1 branch? That doesn't make any sense. Because I know I committed other branches, right? So if I have all these branches I created, why aren't they there? Well, by default, only what you actually commit and push is going to go. What you actually git push up. So one of the ways you can kind of do it all at once is you can do git push master -- all. Oh, is it not master? Origin. Yeah. Git push origin all. So now that's got all your branches up there, yeah? So let's go here. And now all your branches are there. So you can see all these different things that are happening on those branches, the commits you've made, and you can actually kind of dive down in there.
So the fire's almost ready, so we're going to take a break on this, but this tool is essential. This is essential. Whether you're using GitHub or Bitbucket, it doesn't matter. What is important that you use it on your local machine and push your code somewhere else, because if something ever happens to that, if something ever happens to this machine, my code is out there in the cloud. I can buy a new machine, clone it down, and I'm right where I left off, assuming I pushed everything up like you're supposed to. So utilize Git wherever you can. If you're not using it, start. Hope you guys enjoyed this. It was a little longer than I thought. The fire is definitely ready, so I need to go cook because I'm sure my kids are getting a little restless. And So everybody have a wonderful day. It's good to see you again, DIYers. Hope to see more of you soon. Take care.